Hello students, this is Chemistry 280 and we are having a review for the final exam. The first thing that you have to study is how to calculate the percent in mass, for example, or the molar mass or the molarity of a solution. Here we have two examples. If we want to calculate the percent of sucrose, we have to divide the mass of sucrose by the mass of the solution times 100. Remember that solution is solute plus solvent. In the case of molarity, first we have to calculate the moles of sodium chloride by dividing by the molar mass of sodium chloride. When we get the moles, we divide by the liters of solution, remember it's in liters, and we get molarity. That's the formula for dilution. If we want to get to know the volume of the concentrated solution that we have to use to produce a diluted solution, all what we have to do is to multiply the concentration of the diluted solution times the volume that we want to prepare and divide this by the concentration of the concentrated solution. That gives us the volume of the concentrated solution that we have to use to prepare a volume like this in the diluted solution. We study also the solubility curves. For example, which substance is most soluble at 60 Celsius degree? Then here we go at 60 Celsius degree, and we can see that at this temperature, this one that corresponds with potassium iodide is the one that produces a dissolved more solution. More solid, as you can see. You have a solution of sodium nitrate, then you look for sodium nitrate. This is the curve for sodium nitrate, and the question is a solution at 65 Celsius degree, then we go at 65 Celsius degree and contains 140 grams. Well, according with this is this point. This point is above the curve. Then we can say that this solution is supersaturated. Remember that we have here solutions that are on the line are saturated, above are supersaturated, and below are unsaturated. Tonicity is another form of classifying the solutions. For example, isotonic solutions are those that contain the same concentration as in a red cell. Hypertonic when they contain more solute dissolved than in a red cell, and hypotonic the opposite. In A, we see that the cell expands because water goes in. You know that the liquid, in this case water, goes from low concentration to high concentration. Then in this case the solution where the red cell is hypotonic. In the second case is the opposite. We have more concentration outside and water goes out. Thus, hypertonic solution. And in the last case is isotonic solution. Water goes in and goes out at the same rate. You have to explain what is osmosis, that is the movement of liquid water from low concentration to high concentration through a semipermeable membrane, while dialysis is the movement of particles from a high concentration to low concentration through a semipermeable membrane. We We study also pH. pH is minus log the concentration of the hydronium ion, while pOH is minus log the concentration of the hydroxide ion. pH plus pOH is 14. In this case, we have that a solution of hydrochloric acid. Hydrochloric acid is a strong acid, then is completely ionized, and then the concentration of the acid is the same concentration of the hydronium ion. In this case, it's 0.1. Then pH is minus log the concentration of 0.1, that is 1. If pH is 1, then you subtract 14 minus pH and you get pOH, that is 13. And the concentration of the hydroxide ion is 10⁴ minus pOH, then minus 13. If it is a weak acid, you know that we have an equilibrium where we have more molecules than ions. For that reason, it's important to know the constant of equilibrium of the acid. This is given here. The pH in this case will be minus log the concentration of the hydronium ion, but how you calculate the hydronium ion is equal to the square root of the product of the constant of equilibrium times the concentration of the weak acid. In an equilibrium of a weak acid or a weak base, we have to distinguish which one is the acid and which one is the base. The acid always is the donor of protons, while the strong base or conjugate base is the one that is acceptor of protons. In the case of this, the acid is water because it's the one that releases protons, is a donor of proton, and then ammonia accepts one proton and is the conjugate acid in this case. A buffer solution is the combination of a weak acid and a conjugate base, or a weak base plus the conjugate acid. The pH for a buffer solution that is acidic is equal to the pKa plus, that is a given number, plus the log of the division of the conjugate base concentration divided by the concentration of the weak acid. Then you divide this number by this number and you get 20. The log of 20 is 1.30, and you add this to the pKa and you get that the pH of this buffer solution is 7.67. The blood pH normal is between 7.35 and 7.45. When it is lower than 7.35, you suffer of acidosis. If it is higher, you suffer of alkalosis. After this range, it can produce that. Here you observe the equilibrium where the acid decomposes into water and carbon dioxide, and it has to be with the external respiration. And in the other hand, we have the equilibrium of the carbonic acid, that is a weak acid, with the conjugate base, that is bicarbonate. And it has to be, this equilibrium has to be with the metabolism, in this case the kidneys. If your kidneys are not working well, they retain a lot of acid, and then we say that you suffer of acidosis. But what kind of acidosis? Metabolic. If you are running a lot and you suffer of hyperventilation, then you are expelling a lot of carbon dioxide. The concentration of carbon dioxide in blood decreases, and the equilibrium shift from the production to the produced CO2 from the concentration of the acid. Then the concentration of the acid decreases and you suffer of alkalosis because you have more bicarbonate, that is a base, than the acid. But this kind of alkalosis is respiratory. Chemical equilibrium is a reaction that is in a closed container where the reactants reaction, the forward reaction, gets an equilibrium at certain time with the reverse or backward reaction. Then the constant of equilibrium for an expression like this is equal to the concentration of the product raised to the coefficient that they have in the balanced chemical equation, divided by the product of the concentration of the reactants. Le Chatelier principle establishes that when a change is imposed on a system at equilibrium, the equilibrium will shift to counteract the change, then goes in the opposite direction of the change to reestablish the equilibrium. If you increase the concentration of any of the substances, the reactant of the products, the equilibrium will shift in the opposite direction of the increased reactant or product. But if it is the opposite, if you decrease the concentration of a reactant or a product, it will go to reestablish this concentration and will go to the way where the substance is decreased. The pressure and the volume are opposite, as you can see. Then every time you increase the pressure is because the volume is decreased and the reaction shift where you have less moles. Here says more moles. Is the opposite. If you increase the volume, then it will go where there are more moles. In the case of an exothermic reaction, the opposite reaction will be the endothermic. If you increase the temperature, it will shift to the endothermic reaction direction. And the opposite, if we increase if we decrease the temperature, the process will shift where the exothermic reaction is. Remember that we studied the Lamb test to see which one are strong electrolytes, non-electrolytes, and weak electrolytes according with the light of the bulbs. In non-electrolytes, we have only molecules, while in strong electrolyte we have ions. In weak electrolyte, we have both molecules and ions. After that, we studied organic chemistry. And in organic chemistry, we studied alkanes, alkenes with double bonds, and alkynes with triple bonds. We also studied the aromatics, where benzene is an example of aromatics. And also we studied the cycloalkanes. Also, we studied alcohols that are characterized by an OH group and ethers that contains an oxygen between two atoms of carbon. Aldehydes contain the carbonyl group with a hydrogen on one side and a carbon in the other, and ketones has carbon both sides of the carbonyl group. In the case of the carboxylic acid, we have the carboxylic group with the OH and the double bond with oxygen. If we change this hydrogen by a carbon group, we are in front of an ester, and if we change the OH by a nitrogen group, we are in front of amide. The amines are those compounds that contains nitrogen as a center atom, and they can be like this methylamine, dimethylamine, or trimethylamine and this is a primary amine, secondary amine, and a tertiary amine. Remember that amines are very important because neurotransmitters are amines. Here we have the monosaccharides. the most important ones: glucose, galactose,